Hello again, this is the data structure and algorithms, and today I'm going to discuss about the new chapter which is about recursion. Okay, so the concept of recursion will be discussed here, and the slides that I use here I took from the lecture of the book. Okay, so you can check this one, the data structures and algorithms in Python. It is a book written by Goodrich, Tamashi, and Goodwater. So sorry, I took the slides from the book. So let me start with this chapter. So we are going to learn about the recursion, and we will learn about the recursion pattern and the linear recursion and some of the variants of the recursion. First, let's deal with the recursion pattern. What is recursion? Maybe if you think that recursion, some books they mention it as recursive, and you can say that the recursion means when a method calls itself. If you are dealing with recursion, you can see some of the methods it will be called by themselves. The classical example of the recursion pattern is factorial function. Do you know factorial? Yeah, this factorial is about the n exclamatory sign. So let's say if I have 3 factorial, then it is the result of 1 multiplied by 2 multiplied by 3. Okay, so with this recursive function here, it is defined with the fn. So the fn is a function. It will be 1 if we have the n equals to 0. So if it is 0 factorial, then it is 1. Okay. What about if n is not 0? Then it will be n multiplied by fn minus 1. Let's say if I have 4 factorial, okay, then it will be the same with 3 multiplied by, it will be the same with 3 factorial multiplied by 4. Okay, and we can have another. If we already have the 4 multiplied by 3 factorial, then we can split again. If 3 factorial, it is the 2 factorial multiplied by 3, okay, and so on. So we can say that the factorial function will be recursive, or it will be recurse. In the Python method, we can use this function def factorial. Let's say, yeah, I can make this factorial with one argument, which is n. If n equals to 0, then we will stop, or it will be 1. If n is not 0, then we will do n multiplied by factorial n minus 1. So until n minus 1 becomes 0, then it will be 1. Okay. So maybe I will show you the Python code. Okay. So you can check the Python code here. Yeah, we have the factorial and equals to 0, then it is 1. If it is not, then we will have n multiplied by factorial n minus 1. So if I run, sorry, if I run this one, let's say if I want to get the factorial 3, the result is 6. Okay, 1 multiplied by 2 multiplied by 3, then the result is 6. If it is 5 factorial, then the result is 120. So the important thing in the recursive method or the recursion method, we have two, which is the first is base case. What is base case? So in the base case, we want to perform the recursive until no more recursion. Okay? So it means the value of the input variable for which we perform no recursive calls. Okay? So if there is no recursive call anymore, then we can say that is already the end of the recursive. Okay. So if we are dealing with if you're dealing with the factorial, then the base case is 1. Sorry, if the n equals to 0, then we will like stop and the result will be equal to 1. Every possible chain of recursive call must eventually reach a base case. Okay? So when there is no recursive call means, yeah, we will stop. So every recursive method should reach a base case. If you cannot reach the base case, then it's not the recursive method. So the recursive calls, it is a calls to the current method, and each recursive call should be defined so that it makes progress toward a base case. Okay, so this is the key point. So it should make progress towards the base case. Okay. And when we have this recursive factorial, so you can see from this visualization, okay, so this visualization means you can get the way, you can get the result of the factorial by giving the recursive factorial. So for example, if you want to call the recursive factorial 4, okay, after you have the call 4 means you want to have 4 multiplied by 3 factorial. Okay. And then after we have the 3 factorial, we want to get the split again. The 3 factorial is the result of 2 multiplied by 1. So we have this one. 3 is the result of 3 multiplied by 2 factorial. Okay. And then again, we have 2. And then we will multiply with 1 factorial. And then last one, we have 1 multiplied by with 0 factorial. So once we have the 0, then it will return 1. Yeah, we will return 1 and go to the next, which is the 1, and then we will go back to the next stage, which is 2, and then we will go to the next stage, which is 6, and then we will go to the next, which is 24. Then this is the final answer. Okay. So those steps are actually, we call it the recursion. So we will go until the base, yeah? We will go until the base, and after we reach the base, it will return back to the upper part, and we will get the final answer. Now, let's suppose we have a search function. Okay, you know search function. Let's say I have array. Okay, because we are not using array yet. I will discuss also about array in the next chapter, I guess. So let's say this is an array. Okay, so this is an array, and the upper part is the index. Okay, and we have the index. It is from 0 until 15, and the elements of this array has 2, 4, 5, 7, 8, and so on until 37. And let's assume that this array has been sorted. So the common method to sort is to start from index 0 and go to the next index consecutively. So you can, if I want, let's say, I want to find 22. Where is 22? Then I will start from the index 0. Okay, is it 22? No. And then I go to the next. Let's do with plus plus, or we will add with 1. Okay, in index 1, is it 22? No. Then I will go to the next. Is it 22? No. I'll go to the next. Is it 22? No. I'll go to the next. Is it 22? No. I will go to the next. Is it 22? No. I'll go to the next. Is it 22? No. Until we have the, okay, this is the index 10 and we got 22. So how many operations do you need to get 22? That's right. You need to have 10 operations. Okay. 1. Okay. So we will check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, maybe this is 11. Okay, not 10 operations, but the index is 10. Okay. Then If you are having recursion function, it might be less than 11 operations. Why? Okay, let's see. Let's search the integer target in all the lists. So you have already the list, and then I would like to have the binary search. So this is the function that I will create, and the data is a list, okay? And then the target, I want to find a specific value. Let's say in the previous example, I want to find 22. And there is a low and high. And yeah, I assume that the number in the list has been sorted. So the low is in the index 0 and the high is in index 15, for example. Now I will have low is greater than high. Yeah, maybe I will explain with the example first, okay? Let's consider three cases, okay? I want to separate the array, or I want to separate the list into high, low, and mid. Okay, I want to set this and becomes low, high, and mid. Okay, what does it mean by low? Is the lowest one, high is the highest one, and mid is the middle. Okay, now let's see. I have the sequence like this one. I have list. Okay, so the starting point is index 0 and the ending point is index 15. So what is the lowest one? The lowest one is in index 0 and the highest one is in index 15. So we have the mid is 14. Okay, so this is the mid. If we can find the target, let's say I want to find 22. Okay, I want to find 22. So let's see, the target is less than the data in the mid. The target is the less in the data in the mid. 22 is less than 14. Now, then, yeah, we will check again to the next. The target is 22. Okay, the target is 22. Is it greater than the data in the mid? Yes. Okay, 22 is greater than 14. Then we will go, we will check the next, that's the second half of the sequence. It means I do not need to check the first one because I know that number 22 is higher than 14. So I will check the second half. Then I will go to the next one. So I start from the new order, which is the lowest is in index 8 and the highest is in index 15. And then again, I will find the middle value, which is 25. Now I need to check again. If the target equals to the data mid, then stop or we find the target. But 25 equals to 22. 25 equals to 22. No. Then you can check if the target is less than the data mid, the target which is 22 is less than the 25. Yes. Okay. Then we will check the first half. Okay. We will check this part. And then okay, we will have the lowest and the highest value, and we will check the mid. In this case, I have the low, high, mid, and then again, the target equals to the data mid. The target equals to the data mid. 19 equals to 22? No. Okay. And next, we go to the next if condition. The target is lower than the data mid. 22 is lower than 19. No. Okay. So we will again go to the next. The target is greater than the data mid. 22 is greater than 19. Yes. Then we will check the second half. Okay. We will do this one. Okay. And then, yes, the last one is only one value. And the value is 22. And the 22 becomes the low and equals to the mid and equals to the high. Now, how many operations do you need for this one? You need only 4 operations. Okay, you need to have only 4 operations in order to find 22. But what about the previous one? In the previous one, you need to have at least 10 operations. So we have 11 operations. Okay, so in that case, this binary search using the recursion, it is more efficient. If your data is very huge, then using this operation, it will perform much better than the common search function. If the data is higher and if the data is very big, this one will be much better than the previous one. So we can say that in the binary search, it runs O log n. Okay. Why we can say O log n? Because we want to cut at least half than the value of n. What is n? Okay. So in this one, we can say this is the n operation. The worst case will be n. Why? If we know that the n equals to 16, okay, n equals to 16, then there will be 16 times. Okay? There will be 16 times of operation in order to check where is the number 22. Because if 22 is here, then the worst case will be 16. Okay, you need to perform 16 times. But because we are having the 22 is in the index 10, then you don't need to go until the end. What about this one? In this case, even though we have 16 numbers, but we will not do on 16. We can just do with only almost half. Okay, almost half. Okay, it's not nearly half, but almost half. So we can have this is as the log n. Okay, the log n, it means if we have the n equals to 16, so the result will be log 16. Okay, so log 16 maybe is about like more or less 7 or 8 something. Okay, and that's the portion because we have the high minus low plus 1. Okay, so after one comparison, this become of the following. So this is the mathematical if you want to check. So the mid minus 1 minus low plus 1, it will be like low plus high divided by 2. So we can find the lowest value from this one. It is minus low, and it will be lower than the high minus low plus 1 divided by 2. Okay, and we can also do with the high. Okay, from the respective of the high minus mid plus 1 plus 1. So this is kind of the mathematical expression, and if you want to check from the high, it will be minus low plus high divided by 2. It will be lower than or equal to the high minus low plus 1 divided by 2. Okay, so using this expression, we can say that once we use the recursive call, it divides the region into half, into half, into half. So when we cut into half, into half, into half, we just make a kind of prediction that the computation time will take about log n. Okay, so it's not precisely, but in the mathematical or the asymptotic analysis, the DPO is log n because it takes half than the n value. So the things here we want to learn about the linear regression. So you already know the recursion that you learn is having one base case. Okay, so base cases is important. And begin by testing a set of base cases. There should be at least one, and every possible chain of recursive call must eventually reach a base case. Okay, remember that's one. You need to reach the base case, and the handling of each base case should not use recursion. So once you finish with the stopping criteria, it should not be the recursion. And once you have the base case, you need to at least recur once. So you need to perform at least single recursive call. This step may have a test that decides which of the several possible recursive calls to take, but it should ultimately make just one of these calls. Okay, so the linear is one of the function that you can just call one function. Okay, so we will learn about the multiple recursion. It means the recursion will cause multiple functions. Okay, but for the linear recursion, we just want to make one of this call. So define its possible recursive call so that it makes progress toward the base case. So we will just define what is the recursive call, and then we will do until the base case. One of the example is the linear sum. Okay, so the linear sum, I want to have this one n equals to 1, and it will return the a index 0. If we have the linear sum a comma n minus 1, it will be added with the a n minus 1. Okay, what does it mean? If I have the first integer in a, let's say I have 1, 2, 3, 4, 5. Okay, let's say. Then I want to calculate the linear summation. Then I have the value like I want to do the summation of a n minus 1. So this is the value of 5 plus the data that is from 4. Okay, and next can be, now we have a index 4 like this one. Then it means I have the 4 plus the a in index 3. Okay, and then here I can also have another recursion, which is 3 plus a index 2. Okay, and so on. Okay, then we have the recursion trace, something like this one. So we have linear sum a, and then if we have 5, and then we go to n minus 1, 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 and then finally if we reach n equals to 1, it will be the first number. So what is the first number? Let's say this is the first number is 4, and then we go to the next number, which is 3, we go to the next number, which is 6, we get the next number, which is 2, we go to the next number, which is 5, and we get the result. Okay. Maybe you will ask me, why? Professor, why we need to have this recursion? Can we just use the simple addition to have this one? Yes, of course. Okay, but this is another way to use the algorithm. So you can use this recursion in order to make more efficient algorithms. So you already know about the search function. When you do with the search function, you may have AND operation, but when you do with the recursion method, it will cut half. It will solve more efficient. It will solve the problems, and it will result more efficient algorithms. So the reversing array is another example. Let's say I have array. Okay, I have like array 1, 2, 4, 6, 7. Okay, for example, like this one, and I want to reverse. So I want to swap. So the swapping is like I will have like 7, 6, 4, 2, 1. Okay, so it will swap the position. If the first array is 1, 2, 4, 6, 7, and then the result after we reverse, the result will be 7, 6, 4, 2, 1. Okay, how can we do this one? Yeah, you can just check like this one. If I is less than j, then swap. Okay, let's swap, change. Swap is change. So after we change, then we will do again the reverse array a, and then I plus 1, j plus 1. Sorry, j minus 1. So first we will do this swap. Okay. And then after we have this swap, we will go to the plus 1 of I, which is here. And then we will minus 1 from j, which is here. Okay, and then yeah, we will keep continuing until the middle value. So this is the code. If you want to check the code, I already give you the code in the Python. So using the recursive method, it's important to define what the methods in ways that facilitate recursion. So in this case, you don't have the base case. Okay, maybe you will ask questions. Why? What is the meaning here? As you mentioned, from the previous pages, we need to have at least one base case. But here there is no base case. But important thing here is you need to have the condition. Okay, if you don't have the base case, at least you will have also one condition that it will stop your recursion. Okay. The other thing that you can learn from this recursion is about the computing powers. So the computing powers, it means I have like uh, 2 power of 3. Okay, so the 2 power of 3, it can be the same with the 2 multiplied by 2 power of 2. Okay, then yeah, you can have the same idea like this one. So if I have 2 power of 5, then it will be the same with the 2 multiply 2 power of 4. And then yeah, this 2 power of 4 will be the same with 2 multiply by 2 power of 3. Okay, so 2 power of 3 will be the same with the 2 multiply 2 power of 2. And then yeah, it will be computed recursively. And if you do like this one, it will be ON. ON. So you know that every time if you just do with a sequence, 1, 2, 3, 4, 5, then it is just n times. Can we do better than this one? Yeah, in this course, you need to think if you have the algorithm, how can you improve it? How can the computational time is more efficient than the previous algorithm? That's the important. So we can do with the recursive squaring. What does it mean? Okay, the recursive squaring is like this one. If I have the 2 power of 4, okay, like this one, 2 power of 4, then I would like to divide with 2. Okay, if it is odd, then you need to put one more coefficient for this one. Let's say if it is 2 power of 4, okay, if it is 2 power of 4, then you will have the 2 power of 4 divided by 2, and then this is the power of 2. Okay, then after you have this, it means you will have the 2 power of 2, and then you will have this one power of 2. Oh, sorry, I don't know what happened with my pen. Okay, and you will have this one 4 power of 2. Okay, then yeah, this will be simplified, so you can just reduce the number of computation. You don't need to have the 2 power of 4, and then 2 power of 3, and then 2 power of 2, okay, 2 power of 1. So it takes like n times. But if you do like this one, then you will have shorter. You have like almost half. In this case, you have 4 operations. In this case, you have only 2 operations. Okay. The same with if you have like 2 power of 5. Okay. So 2 power of 5, you will do with 2 power of 1 plus 4 divided by 2 power of 2. Okay. So if you have 2 power of 5, okay, then it will be the same like with 2 multiplied by 2 power of 4. Okay, and what is the 2 power of 4? The 2 power of 4 can be divided into 2. 4 divided by 2, and then you will multiply with 2. Okay, so this is the result of the 2 power of 2, and you will do this result and do the power of 2. Okay, and so on. So the operation time will be much slower. If you have the previous power, computing power, you will have the 5, and then 4, and then 3, and then 2, and then 1. Okay, so 2 power of 5, 2 power of 4, 2 power of 3, 2 power of 2, 2 power of 1. So there will be 5 times. But using this one, you will have only 2 times. So 1, 2. Okay, so which one is better? 5 operation or 2 operations? Of course, you will choose 2 operations. Okay. So this is the function. If you want to do this one, this is the recursive squaring method. If n equals to 0, then it returns 1. If n is odd, then you need to use the power x, and then you need to multiply the n minus 1. This is the power. Okay, this is the exponent, n minus 1 divided by 2. But if it is in even number, then you just have x, and the exponent is n power of 2. So this is the explanation. Because we divide with 2, so the operation time will be like half than the n power. So we can say that this recursive method produce O log n. So it is important that we use a variable twice here rather than calling the method twice. Okay. So if you want to check more about this, I already gave you this Python code. The first is about the binary search. This is the binary search that we already learned before. If you run, and then if you have the data like what we already saw in the PPT, okay, you can just check the binary search. I want to search 22, and then I know that the lowest one is in index 0, and the highest one is in index 15. So if I run this, okay, I can find the number 22. Okay. Next is about the reverse. I also give you the example of the reverse. This is the function of the reverse. And let's say I want to reverse the data. So what is the data? Data is here. So I want to reverse the value. This is from 2 until 37. Okay. I want to reverse. So the result will be a reverse. So the 37 will be in index 0, and 2 will be in index 15. And about the power, yeah, you can know that in Python there is a function power, P-O-W. It means if you have 3 power of 2, then it result 9. Yeah? If you have 3 power of 3, then it will show you the result 27. Now I want to make it more in a better way. Okay? So in a better way, it means I want to reduce the computational time into half. So the power, this one, it shows the ON, but I want to make it O log N. So using the function that we learned in the PPT, you can have the same, this one. Yeah, the result is the same, but if you run with a very big number, the computational time will be less than the power, the general function in Python about the exponent. You can check if you want, yeah, but I think nowadays the computer has a very good specification. Then even though you have a very large number with 1,000 or 10,000, it still show a very good performance with very good result. So in this case, if I run this one, yeah, it shows like 0 second. Okay, if you want to do with more numbers, I guess it is, yeah, there will be an error because the number is too large. Okay, so you need to use another data type in order to fit with your experiment. Okay, so I will stop here. I will continue the next thing. I will continue with the recursion variants in the next video. So thank you for listening. See you.